Okay. Okay, let us revise the yesterday session. Yesterday I have just introduced about the POJO class. The POJO class is just an ordinary class, and if it is extending or implementing only to the Java library, we can conclude that the class is a POJO class. It should extend only to the Java libraries, JDK libraries. Apart from JDK libraries, if it is getting extended or getting implemented to any other libraries, we do not call it as a POJO class. The name itself indicates that POJO is an acronym for plain old Java object. Means it is a word. It is similar to a class that is going to follow its traditions. It's a traditional old class. It is not going to get the class upgraded to or implemented or extended to the new libraries apart from JDK. As simple as that, right? And I have just given some introduction. So let us discuss about this a little more, because we need to understand few more things about this POJO class. After completing this POJO class, we can discuss about an interface which is called as POJI interface. So let me copy this. Okay. This diagram is very important to understand today's topic. Okay. Okay. So yesterday we have also discussed about the JDK kit. If you download JDK, the JDK software gets downloaded in the downloads folder. Right? After installation, it is going to get separated into what? It will get installed by default in the program files, which is inside the C drive. Will automatically create a folder called Java. Inside Java folder, if you go and check inside the Java folder, again there will be two subfolders. One is meant for JDK. Here you will find all the tools related to the Java development, and another kit is meant for what? Another folder is meant for JRE, Java Runtime Environment. In this folder, you will be finding rt.jar file. Right? Understanding this rt.jar file is really important, because all the predefined Java classes are related to the JDK library. All the libraries will be present in this rt.jar file. Right? For example, let us say that I am writing a simple Java class. So this is my Java class. So I am identifying this Java class with the name test, class test. Right? This is a developer code. Right? This is a simple Java code. I can call this class as a POJO class. Why this can be called as a POJO class? You see this code. Firstly, internally, few things will happen. You cannot compile this code directly. Firstly, you cannot run this code directly. Before even running this code or executing this code, you need to perform the compilation. In order to perform the compilation, you need to save this particular code in a particular file. For example, let us say that I am saving this code as test.java. Right? I have used a notepad to write this code, and I have saved this code with the name of test.java. Right? So I am choosing a folder. I am choosing the D drive to save this particular file. So now this file has been saved inside the D drive. Right? My Java is located in C drive. Java has been installed successfully in the C drive, but I am preferring to save this particular Java file in the D drive. Okay. After saving, it has to go through the compilation. Right? For compilation, compilation will be done. Right? The compilation command will be inside this particular folder. Compilation command and execution command will be there inside this folder. you will find commands related to compilation, which is nothing but Java C. Commands related to execution, it is nothing but Java inside this folder. Okay, let us say that this code has been successfully compiled. After compilation, bytecode will be generated. Once the code is compiled successfully, it has to go through the execution. Right? Now tell me, when this code is about to get executed, right? The compiler, after compilation, the compiler is going to add few things. What are they? It will extend this file to object class. Firstly, compiler will ensure that this particular class is getting extended to what? Object class. Extends to object class. Okay. During execution, as after compilation, so understand one more thing. After compilation, dot class file will be generated. This is completely core Java concept, but we are discussing these things on top of core Java concept for the better understanding, so that you will understand what is a POJO class. Test.class file will be generated after compilation. Right? When you perform the execution, when this test.file is encountering an execution, right? It will check if this particular class is extending to some external libraries. It is not extending to any external libraries. It is extending only to the object class. Right? This object class is available inside rt.jar file. Right? It will check for whether this object class is available inside the Java development kit, which has a separate folder called rt.jar. If it is available here, the conclusion is very simple. This is a POJO class. Right? This is a POJO class. Why? Because all the libraries that are required to compile this particular code is available in rt.jar. Right? This is a POJO class because compiler will use all the libraries like the JDK kit. Because no external library is required to compile or execute this program. No external library is required because it is not dependent upon the external libraries. So another example I am giving you. This is another example. In this example, we will try to extend class test1 extends HTTP servlet. So if you see this HTTP servlet, during compilation, the compiler will check if the HTTP servlet is available in rt.jar file. It will not find this particular library inside the rt.jar file. Why? Because this HTTP servlet is not part of Java library. It is a part of the library given by the servlet API, a third-party library. Please be informed that the HTTP servlet is not part of Java library, and it is the part of third-party library or servlet API. So this is not a POJO class. Not a POJO. So yeah, the conclusion is very simple, isn't it? If the particular class is extending or implementing to a third-party library, it's not going to be POJO class. If it is extending only to the libraries that are related to Java API, JDK APIs or JDK libraries, it is called as POJO class. So now I can give another conclusion like POJO classes are not against to extending or implementing APIs. They are against only to extending or implementing the third-party APIs, Java APIs or JDK APIs. They are against only to extending or implementing the third-party libraries or APIs. One conclusion I can give like this. Right? And the second conclusion can be, I can also say that second conclusion, object-oriented OOPS concepts, OOPS, exceptional handling, things, AWTs, collection APIs, collection framework APIs, reflection API, etc. These APIs are part of Java languages, So there will be no problem if a particular class is extending to the Java APIs, because these are the old APIs. That's why it is called as a plain old Java, plain old principle. If it is extending to the same APIs, no issues. It can be still called as a POJO class. But the problem is here, it is trying to extend to like APIs like JDBC, servlets, ASPs, Java server pages, EJBs, enterprise Java beans, etc. These are not part of Java. These are not part of JDK kit. These are part of Java technologies. If a particular class is extending to these APIs, they are not called as a POJO class. Right? And what is an advantages of developing a class as a POJO class? That understanding is very much required. For example, if you talk about frameworks like Spring Boot is nothing but an extension of Spring, Hibernate, and Spring REST. These are the frameworks. Spring REST. They are Java frameworks. These frameworks support POJO class modeling. This framework supports what? POJO. You can design the Java classes with the POJO class modeling. Let me give you a real-time example. So this Spring framework is saying like, developers, you can come and use my Spring framework. You can develop classes with the POJO class model. If you want, you can use my framework as long as you like. If you don't want, you can leave. It's up to you. If you want, you can use as long as you can. If you do not want to be under my framework, you can leave at any time. That is the flexibility these frameworks are giving. One is Spring Boot, Hibernate. That much flexibility it is giving. But if when you choose technologies like JDBC, servlets, EJBs, it is like it is getting coupled directly. It is saying like, if you are using me, you have to use as long as you die. Do not even think about leaving my technologies. Once you started using me, you should be using me as long as you die. If you like another future, if you like another technology, you will not get any opportunity to jump from my technology to that technology, because these futures are like they are tightly coupled in nature. Tightly coupled in nature. And using frameworks like Spring, Hibernate, it is giving us an advantages are like it is by is loosely coupled by nature. By nature. As long as you like to be in my framework, you can stay with me. If you don't like my framework, you can jump to the any new feature. For example, in future there might be some additional frameworks that we can anticipate, right? If any new framework is coming in the market, the project can be easily migrated from the Spring to the new future. That kind of advantage we are getting by using the Spring frameworks. But the same thing, if you I mean the same project, if you develop on top of these technologies are like, you can use me but you cannot leave me. Once you started using me, once you start building project on top of these technologies like JDBC and serverless, you are not allowed to do the migration, because migration is going to be the costly operation. You need to change the entire program, because each and every application is a loosely tightly coupled in nature. Same example, POJO means what? It is just using the rt.jar file, right? If I just use this kind of model in Spring framework, it is just using what? It is just using Java libraries, right? So migration is very easy. In future, if I want to migrate, I can just copy this code. I can just paste it in the new project, or in the new framework, right? If you take this as an example, if you want to do the migration, I need to carry this HTTP servlet along with me. It is not possible. I cannot I cannot lose this HTTP servlet tightly coupled, because this is a different framework. We are just trying to extend. We are just trying to use a different technology from the third party library, tightly coupled. Any business logic is written inside this particular program. This business logic is completely dependent upon this HTTP servlet API, which is a third party application, which is a third party library, right? So migration is very difficult, right? That flexibility is not there. So the Spring frameworks are giving such flexibility. It is asking the developers design the Java code by using the POJO classes, POJO class model. Right? If you are able to design the codes like this, in future, if you want to do any migration, you would like to jump from one platform, from one framework to another framework, it is going to be very easy. Right? That's why we are going for what? We are going for POJO class development model. Right? Making sense? Right? So this is what we call it as POJO, plain old Java object. And if you ask me what is that tight coupling and what is that loose coupling, it is going to be like this. Let me let me use this space. For example, if I am going to develop a Java program only with POJO classes, there's no space. Let me use this. I'm just using POJO classes. So POJO class 1, POJO class 1, POJO class 2, POJO class 3, POJO class 1, 2, 3. I have 4 POJO classes. Since they are not tightly coupled, they are just loosely coupled. Loosely coupled in the sense, this is how it looks like. This is a simple diagrammatic representation. How it looks like. They are not tightly coupled. They are loosely coupled with each class. Each and every circle is representing a class, right? So all the classes are using the same JDK libraries. So migration is going to be very easy. This is how the loosely coupled applications looks like. This kind of applications can be developed on top of Spring Framework. But how the tightly coupled application is going to look like? This is how it is going to look like. You talk about tight coupling. It's like it gets bombarded with each other. These 4 classes will looks like this. I have a problem with my mouse. Okay. You take four classes. These four classes are this is how it is going to look like when you imagine it from the diagrammatic perspective, right? So tightly coupled application looks like this, and a loosely coupled application looks like. If you want to migrate, if you want to make any changes with one classes, the changes are going to be very easy. That's what I'm talking about. I can simply remove this class. For example, I can simply remove this class. I can add a new class. There will be no issues. But in this case, removing one class is not possible because each and every class is dependent upon each other. They are tightly coupled. Right? So, what are the advantages of developing projects on top of Spring framework? The advantages are going to be like this. We can say less interdependency. Each and every classes inside the application is going to be independent of each other. So developing testing applications will become more flexible. Coordination. The third one is what? Less coordination, and less information flow. So tightly coupled applications will be like more dependency. More dependency, more coordination, more information. You will understand this when we start working on the first Spring application. So these are just a kind of little information about what is tight coupling and what is loose coupling. You can develop loosely coupled application on top of Spring framework. Right? How we can achieve that? By using the POJO classes. Why by using the POJO classes? Because POJO class does not depend upon the external libraries. What are the advantages if it is not depending upon external libraries? Right? If it is depending upon external libraries, it is like we are keeping it as a tightly coupled application. As simple as that. Tight coupling, loose coupling. These are some few information that I give. But there are some exceptions. Right? Let me write few pieces of code, and now you will have to tell me which one are POJO classes and which one is not a POJO class. Okay, shall we start? Let me use this space. Case 1. So there is some reason behind discussing this because there are some exceptional cases. I want to discuss about those exceptional cases. Now you type in the chat box whether this is a POJO class or whether this is not a POJO class. Class test friends set. POJO or not POJO? Just type yes in the chat box. If POJO means type POJO, non-POJO means type not POJO. POJO class. Yes, it is POJO class because this thread is a class which is part of Java Lang API. Thread is a class part of Java library. Thread is a part of Java Lang API. Right? And we have already discussed about the second case too. So there is a lot of reason behind this POJO classes because we use this terminology very often. So when we develop first Spring application, the things will become very easy. We'll understand so many things in the future. Understanding this POJO class is very imperative. Okay? Second class, public test 1 implements java.rmi.remote. POJO or not POJO? But I will tell you this remote is not part of Java API. This interface is not part of Java API. If this is not part of Java API, it is a POJO class or not POJO class? Pandu Tirumala, please respond. Only Madhu is responding. This is not part of Java API. POJO or not POJO? Not a POJO class, yes. Not a POJO because it is not part of Java API. Not a POJO class. POJO class. You will have to understand, very simple. Just check whether it is implementing any class or interfaces. If it is implementing any class or interfaces, check if the interfaces are belonging to the Java package. If it is belonging to the Java package, it is a plain POJO class. If not, it is not a POJO class. As simple as that. Last example, case 3. Class test2 implements java.sql.connection. POJO or not POJO. This SQL is not the part of Java API. It is a part of JDBC technology. So it is not a POJO class. Okay, we know all this. We have seen this all things yesterday. What is the point of discussing this once again? That could be your question, right? I'll tell you why. So this, by looking at this, we can say this is a POJO and this is a not POJO. That's by looking at whether the class is extending or implementing any interfaces, right? And one more case is there. But just tell me if this is a POJO or not POJO. Class 3. Is it POJO or not POJO? Make it quick. Tell me whether this is a POJO or not POJO. This one. POJO class or not a POJO class? POJO. Because it is not extending or implementing. By default, it is going to be object class. Object class is a part of Java API, so it is a POJO. POJO. Cases are completed. Now your question could be: we have discussed these things yesterday. What is the point of discussing this over and over again? Now another example I'm going to give you. Let me use this page. Now tell me, class demo public static void method 1. So I have taken a method 1 inside a class demo. Inside this method, I am using Hibernate APIs. Now tell me, this is a POJO or not POJO? Hope you're able to understand this. This is an exceptional case. This is an exception case. So it is not extending or implementing to the third-party APIs. Okay, it is that we can say, right? It is not extending or implementing the third party. It is not using extends keyword or implement keyword, and it is not implementing to or extending to any interfaces and classes. But inside a method, it is using an Hibernate API. Hibernate APIs are third party API, not part of Java package, right? Still, this is called as a POJO class. Is called as a POJO class. Why it is called as a POJO class? You can ask me why it is called as a POJO class. I have just mentioned that dependency should not be there with the third-party APIs, but here the dependency is there. Of course, dependency is there, but dependencies are not in the form of extends or implements keyword. Dependency is part of the method, part of the program. This is the exceptional case. This is called as a POJO class, even though it can't be compiled only using the JDK library. Can't be compiled only using the JDK library. It requires Hibernate library. Only if it is extending or implementing the third-party APIs, we call it as, we can conclude that it is a POJO class or not a POJO class. This is one exceptional case. What is an exceptional case? If it is using a third-party APIs or libraries inside a method or inside a class, right? Still it is called as a POJO class because limitations are only for the extends and implements keyword. Hope you are able to understand. This one case. Second case is case 2. Same class I am taking. Same class. So instead of taking the third party APIs inside a method, I am simply using an annotation. We'll discuss about annotations in the future, but just try to understand the concept. If I use an annotation like entity at the rate, if I had to compile this particular class, I need to use entity. Entity is falling under the Hibernate API. I'm using an entity annotation. Annotations are nothing but if I declare something with the at the rate keyword, we call them as annotation. These annotations are going to give a special meaning to a particular class. It is going to add some libraries. Of course, this is an Hibernate API annotation. But still this is called as a POJO class. Why? Because the limitations are only for extension implementation keyword. It's called as a POJO class even though it can't be compared only using it requires Hibernate label. But still it is called as a POJO class. POJO class because the limitations are discussed or defined only on the extents and implements keywords. Making sense? This is the conclusion, right? From this conclusion, we can also conclude one more thing. What is another conclusion is that POJO class need not to follow Java Bean class standards. So previously we have discussed about the Java Bean class. Java Bean class is something that is following some standards or that is following some conventions. There are some rules to define a particular class as a Java Bean class. I can conclude like conclusion. You can say note. All the Java Bean classes are called as POJO classes, but not all the POJO classes is called as Java. It is like all the students, all the faculties or students can be students, right? But not all the students can be faculties. Similar way, I can say all the Java Bean classes are called as POJO classes, but not all POJO classes are Java Bean class. You see Java Bean class is not extending to any third-party library. In the at most, in one case, it is extending only to the serializable interface. Again, the serializable interface is part of Java API. That's why it's called as POJO class. Why? At most, Java Bean class extending only to the serializable interface, which is part of Java API. That's why it is. That's why we in the Spring or Spring Boot framework, the entity class or the class that is carrying the data, we often call it as a POJO class. Specifically, if you want to call it, you have to call it as Java Bean class. Right now, I think you can able to differentiate between what is the Java Bean class and what is a POJO class. If you want to differentiate about Java Bean class, there are 5 rules which I have already discussed in our second session. Right? If any class is following those 5 rules, they are called as Bean class. Right? If any classes is following rules that is related to POJO, what is that? It should not extend or implement to the third-party APIs. Right? That is called as a POJO class. And Java Bean class is also called as a POJO class, but not all POJO classes is called as Java Bean class. As simple as that. That's why it is often called as Java POJO class. We will discuss these terminologies going forward. Very often we are going to use these terminologies in our Spring application. If we are developing Spring application without understanding these terminologies, there is no point of, we cannot understand developing the first Spring module, core modules. Making sense? So this is the important note that you must understand. Now I think you can differentiate between Java bean class and the POJO class. Right? Secondly, second note, first note. The Java bean class, we cannot have any business logics. At most, we can have what we call it as properties. We can have setters, we can have getters, we can have constructors, and we can also have hash code method. We can also have equals method, right? But in POJO classes, we can also have business logic. POJO classes can also have complex business logic without having with less API dependencies. So the important point is Spring framework supports POJO class modeling. POJO classes modeling to achieve loose coupling. Loose coupling. Achieving loose coupling is nothing but, for example, see, this is my project. From developing project, top of Spring framework, right? I am using some technologies, right? By using a language. Project Spring technology 1, technology 2, technology 3 by using Java language. So technology 1 is, these technologies are built on top of Java language, and the Spring Boot, the Spring framework is built on top of technologies. I can use like this. And my project is built on top of Spring framework. Okay. So if I build a project on top of Spring framework, since it is supporting the POJO modeling, in future, if I don't like this Spring, I can just move the Spring, right? I can develop any other framework, as simple as that. I can use some framework like what? Let us say any XYZ framework. In the future, if any new framework is coming into the market, migration becomes very easy, right? And again, if I don't like this future, this future framework, because after using only we'll come to know whether this framework is good or not. So if I don't like this, I can go back to the Spring itself, right? That much flexibility we will get by using the Spring framework because it is supporting POJO class developing algorithms. Can develop classes by using POJO class modeling, as simple as that, right? Making sense? So it is all about the POJO classes. Now we will understand what is POJI. POJI is an interface, plain old Java interface. Right? So one more conclusion let me write. These things are very important for interviews. Fourth conclusion, fifth conclusion. Spring supports POJO and POJI model programming, which means classes or interfaces Is of the Spring project or applications can be taken as an ordinary POJO class. POJO classes and ordinary interfaces. Ordinary interface and ordinary POJO class means they are not extending to the external libraries. The traditional practice that you follow while developing a program, traditional practice, the old practice, plain old Java objects or plain old Java interfaces. POJI, without any dependencies. With Spring APIs. Or we can say with less dependencies, not without, with less dependencies. So if you achieve this in future the migration from migration to the new framework becomes very easy. Yes, the project is loosely coupled with the framework. So Spring is saying as like the Spring documentation is, if you want to develop project on top of my framework, you can develop it, and you have advantages. Advantages are like in future if you want to migrate to the new framework, you can do that without any issues. I will not stop you. At the same time, after migration, if you want to come back to me, you can come back to me, no issues. That much flexibility the Spring frameworks are giving it to the projects. Right? From this diagram, you can understand migration is just like can happen very easily. With other frameworks, it is like you need to make the lot of changes to the existing project. Right? If you are giving commitment, it is just like a marriage with the JDBC framework or with the with the old technologies. Marriage is like commitment, right? Once you married, it is like 100% commitment. You should live as long as you exist. Likewise, if you're using Spring framework, it is just like a friendship. You like, do friendship. You don't like, you go. Right? Making sense? Right? So understanding POJI is very easy. Same concept applied for POJI. Right? POJO is nothing but plain old Java object. POJI is plain old Java interface. POJI is an interface. The interface is extending. Right, okay. It's an ordinary interface without any specialities. Old interface, no specialities, same old traditions. No, it is not API